This is section 5.6. It is direct variation. So the formula you always need to keep in mind for direct variation is this y equals kx. And this k is called the constant of variation. Now, in layman's terms, what direct variation means is as one thing increases, the other thing also increases. So things that could have a direct variation would be like my height and my shoe size. Or even like height and weight, like things that you would expect to go up together or go down together. So like if someone was shorter, you might expect them to weigh less than someone who's taller. So when you have things that vary directly, it just means they change in the same direction. So one thing goes up, the other thing also goes up. This constant of variation, truly what this is going to be your slope. And you don't learn really about how slope fits into all this until the next section. But your constant of variation is just how rapidly things are changing together or how slowly things are changing together. If you were to solve k by itself, you're going to get, so this is the equation, y equals kx. Well, you've learned before that you can solve for a variable. So if I needed to get k by itself, I would divide both sides by x. So y over x equals k. So my constant of variation is just taking the y number divided by the x number. You know that something is a direct variation if and only if it can be written exactly like this. So I'm just going to do some example problems from your book to talk about these things, but the real formulas you want to know is truly just this one, because that's the formula for direct variation. You also want to make sure you can change it into this, that you understand y over x is how we get k. And I think this will make more sense when we just start doing examples. So let's see. I'm on page 339. And if I look at number 2, it says y equals 4x plus 9. And they want to know, is that a direct variation? And quite simply, the answer is no, because of this plus 9. This is not a direct variation. Direct variations are always going to cross through the 0, 0 point. Direct variations will always cross through here, no matter how your slope goes. You can't have this added on number. Another one, it says number 3 is 2y equals negative 8x. This is going to be a direct variation. The reason it is a direct variation is because it can be rewritten to look like this. So if we just divide by the 2, you're going to get that y equals negative 4x. So this particular equation, yes, that is a direct variation. If they asked you what's the constant of variation, well, that's this number, negative 4. That's our k value. They're also going to ask you to look at like ordered pairs and to see if something is a direct variation. So let's say you have like an XY table and they're telling you 10, 5, 2. And then this one is 12, 7, 4. what you need to do is just see, is there a k? So if you do 12 over 10, because we know that k actually is just y over x, 12 over 10 is 6/5. 7 over 12, or 7 over 5, well, that's not 6/5. So these don't have a constant k. This one gives me 6/5, this one gives me 7/5, this one gives me 2. Since there's no constant k, you would say this is not a direct variation. And it's just because k is just y over x. If all those y's over x's are the same thing, then you've got that. So let me give you one that is. If you had, let's say, your x's are 3 and -1 and -4, and your y's are -6 and 2 and 8, well, this time when I do y divided by x, I get -2. When I do y divided by x, I get -2. Y divided by x, -2. So this is one that, yes, that is a direct variation because there's just that constant y over x. And eventually you guys are going to learn that this y over x thing, that's your slope. So let's see. What I know last year students had some confusion on was the further problems, like on page 340, number 20. If you're given an ordered pair, like 210, and they ask you to find the k value, and they ask you to then graph it. This is your x, this is your y. So your k is just, again, k is y divided by x, so your k is just 5. If you need to graph that, the way direct variations always graph is they always start with 0, 0. And then you just need to draw a line that this k, this is actually your slope. So you need to draw a line that has a slope of 5. So you're going 1, 2, 3, 4, 5, and then over 1. That would be your graph. Perhaps an even easier way to think about the graph is if I just told you it always goes through 0, 0. That point will be there 100% of the time. Just plot this as your other point. So plot 0, 0, plot 210, you've got a graph. But if they're asking what was the k, you're just taking this y divided by x. So I'll do another one. I'll do number 21. So number 21, it gives you the point -3, 9. Well, that's my x, that's my y. If I needed to find my k, I just divide those. So my k is -3. And then if they ask you to graph it, you can really just graph the point 0, 0, and then graph the point that's given, that -3, 9. So 1, 2, -3, and then up 9, and then cut off. And that is basically what direct variation is. It's always going to be linear. It's always going to pass through 0, 0. And there's always going to be some constant. Things are either going up together or they're going down together. And that's why you always have that constant k.